Welcome to The Explainer. So, you've probably heard a ton about generative AI lately. It kind of feels like it just appeared overnight, right? But the truth is, this incredible technology is actually the result of a 70-year story. It's an amazing journey of breakthroughs, setbacks, and brilliant ideas. Okay, just look at this comparison. It's pretty wild. On the one hand, you have Eliza from way back in 1966. Its big move was basically just repeating your own words back to you, like, tell me more about your mother. On the other hand, you have today's AI, which can whip up a complex, creative poem on demand. So how in the world did we get from A to B? To really get it, we need to go all the way back to the beginning. All right, let's start with Chapter 1, The Age of Rules. This whole thing kicked off in the 1950s, and here's the key. Early AI wasn't about learning at all. Nope, it was all about pure logic, about building systems that followed a very strict set of rules that humans had painstakingly written out by hand. The best way to picture this is to imagine a chef who has the world's most detailed recipe book but has zero ability to improvise. That was the AI. It had this giant knowledge base, this book, full of facts and if this, then that rules. You'd ask it a question, and it would just flip through its pages to find the exact matching rule and spit out the pre-programmed answer. And don't get me wrong, for its time, this was really, really clever. This approach gave us some groundbreaking stuff. You had Eliza, that chatbot that mimicked a therapist. And then there was Sistran, a translation tool that was so surprisingly good, it was still being used for some web translation all the way up until 2007. I mean, that's a pretty good run. But, and this is a huge but, this whole approach had a massive fundamental weakness. These systems were brittle. You could snap them, figuratively speaking. The second you gave them a situation that wasn't explicitly covered in their rulebook, they would just break. They had absolutely no way to adapt or handle the unexpected. So to get past this roadblock, researchers had a big aha moment. A rulebook just wasn't going to cut it. AI needed, well, it needed something like a brain. The mission changed. The new goal was to build machines that could actually learn from experience and data, not just follow a list of instructions. And this shift was a total game changer. The focus of AI research completely flipped. Instead of trying to interview experts and write down everything they knew, the new thinking was, let's just collect mountains of data and let the machine figure it out. We went from these so-called white box systems, where you could trace every decision, to these new model-based systems that learn the patterns all on their own. Now, as you can see here, this wasn't an overnight revolution. Not at all. It was a slow burn, a patient process that took decades. You see these statistical methods pop up in the 60s, then in the 80s, this super important idea called backpropagation starts to get popular. That's the core technique that lets a network learn from its own mistakes. And believe me, it is still fundamental to how all this works today. So all of that slow, steady progress over the decades was quietly setting the stage for an absolute explosion. And that explosion happened in the 2010s. This revolution was powered by two main things. First, unimaginable amounts of data, and second, a powerful piece of hardware that, funnily enough, was built for video games, the GPU. Then, in 2017, a paper came out introducing something called the transformer architecture, and it literally changed everything. Its secret sauce is a clever mechanism called self-attention. What it does is let the model look at an entire sentence or a whole document and figure out which words are most important to one another. That's how it understands context. And it was an absolute breakthrough. This whole deep learning revolution gave birth to all these new, fascinating types of models. First up, you've got GANs, or Generative Adversarial Networks. The way these work is just brilliant. You have two AIs battling each other. One is an artist trying to create a realistic image, and the other is a critic trying to tell if the image is a fake. This duel forces both of them to get better and better until the artist can create stuff that's practically indistinguishable from a real photo. Then you've got VAEs, or variational autoencoders. I like to think of these as the dreamers of the AI world. What they do is learn the absolute essence of a ton of data, compressing it down into this abstract idea space. And then they can pull from that space to dream up new, varied creations. The results can sometimes be a little bit blurry, kind of like a real dream, and that brings us right to the cutting edge, especially for making images. Diffusion models. These are the sculptors. It's wild. They literally start with a screen full of pure static, just random noise. And then, step by step, they carefully refine it, chipping away at the chaos, like a sculptor carving a masterpiece out of a block of marble, until a perfectly clear and detailed image emerges. So, what happens when you take these incredibly powerful deep learning models, especially the transformer, and you just scale them up? I mean, you make them bigger than anyone thought possible, and you feed them more data than you can imagine? You get what we now call a foundation model. These are the giants you know and probably use today. We're talking about models like GPT, Llama, and Gemini. They've been trained on a huge slice of the public internet. And because of their incredible scale, something amazing happens. They start to show off what researchers call emergent abilities, skills that nobody ever explicitly programmed them to have. They just figure it out. But just being powerful isn't enough. They also need to be helpful and, safe. So how do you teach them that? A really key technique is called reinforcement learning with human feedback, or RLHF. It's actually a pretty simple idea. Humans look at different AI answers and rank them from best to worst. That feedback is then used to train a separate reward model that learns to predict what humans will like. Then, the main AI is fine-tuned to give answers that will get the highest score from that reward model. It's literally learning to be more aligned with what we want. So, this incredible new power brings us right up to today. Generative AI isn't just a research project in a lab anymore. It's a global force that's already changing our world. But, as you know, with great power comes great responsibility. And the technology is now at a really critical crossroads, facing some very big challenges. Let's be real, as amazing as these models are, they're far from perfect. They have a big problem with hallucinations, which is a nice way of saying they sometimes just confidently make stuff up. They can also fail at very basic reasoning. A huge challenge is the black box problem. We often don't know why they gave us a specific answer. And this is all on top of the fact that it costs millions of dollars and a staggering amount of energy just to train one of these things. So after this entire 70-year journey from simple rules to world-changing models, it all comes down to one final critical question. This technology is learning and evolving at a pace that is just dizzying. The question is, are we, as individuals, as companies, as a whole society, are we learning fast enough to understand this technology, to manage it, and to make sure we use it responsibly for the good of everyone? That's the real challenge that lies ahead.